Okay, so my name is Filip Zawadiak, and I also had a kind of a hobby project that started 5 years ago, and since like 4 years became a company. And since the beginning, we kind of decided the product will use Lua. So we are in like the middle spectrum. It's not so small as the eLua, but compared to what all of you use Lua on, we actually run in this thing home automation integration servers. So it's kind of a very small hardware. I have one device hanging here, so in the end, I will be talking about something like that. So a few words about DOMIQ. So we are developing something like a home automation integration servers. Currently, we have like this main module that I have here, and a number of extension modules that connect to it, that connect to different automation systems. So there is the problem with home automation is that you have a very, very large amount of standards to choose from, and they are very different in states compared to Europe. One of them used to even have the E for Europe in the name. So we usually work with something called LCN that's quite popular in Poland, in Germany, and some other countries. And also with things like Modbus. This is like a standard automation integration protocol. Also with Lightning, like DMX, intrusion detection systems. Kind of peculiar thing we do is that actually the volume for such devices, it's not very large. So we had to make choices to make it affordable for us to manufacture, to make it affordable for customers to buy, because it's usually homeowners that buy them. And since the very beginning, we decided that all the software should be upgradable inside those modules. So there is not a single CPU inside that's not remotely upgradable, which allows us to make bugs, which we can fix later. So we do quite a lot of software releases. Also to add new features. That's another thing. We don't want to leave customers behind. So as a main thing, all the new features for all our customers are available for free. So for some of you, kind of what's specific about this home or building automation systems. So those are not kind of very real-time systems. They are usually not critical in a sense that somebody will die if they fail. But people complain if they are not performing fast enough. So typically it's something like 500 milliseconds is the kind of expected response time for the system. So if it's more, then people start to complain, for example, that they entered the room and the light was not on. You perceive that. It's very irritating if you are used to that the light is always on. Then it's a shock that it's not. With all the standards I was talking about, they are really, really slow networks. Usually it's like serial protocols running with some strange voltages or some additional Manchester encoding. And the speed, it's usually something around 10 kilobits. The price for entire installation for a home, for our customers we do, that's roughly $10,000 to $50,000. Most of it is spent on the devices that are actually doing something, like the actor devices. So I have with me one of the LCN modules, and this box has like 2 dimmers, some binary inputs, ability to connect a keypad in front, the temperature sensors, and basically you put them usually in the places where you have wall switches. And also something that we wanted to do from the very beginning is that it should be easy to do easy things, and it should be possible to do things that are sometimes weird and very unusual. So since the very beginning, we have exposed the Lua programming to customers, which are electricians. And they start to program. I mean, that took like 2 years, but they learn. So outside of the a typical installations for us, like homes and flats, that's less typical. We have our modules in some very big buildings, like a 60-floor office tower in Germany, in a hospital in Barcelona, when it's actually controlling lighting in the operating rooms and the intensive care units to make the colors go nice, like sunset to sunrise, sunrise to sunset. And recently, one of our installers finished doing like a very nice church visualization systems. But the point I'm here is not to talk about home automation or building automation, but Lua. And we are actually using Lua in many, many places. So this device, the base, it's basically a Lua computer. I mean, it doesn't do anything except running Lua. And the operating system it runs is designed to make running multiple Lua states in parallel with some communications between. And that's the part I will spend most time talking. We also use Lua in other things. We have like a touch panel product that also has entire UI, networking, everything is implemented in Lua inside, but this is running on Linux, so it's more typical way Lua is used. We also have like a central servers that enable customers to connect these devices at home with the remote application that's running on the iPhone, iPads, without any network tweaking. So it's also written in Lua. I tried to write it in Java also, but I mean, the server in Lua is like 4 pages of text, and after writing like 15 Java, and it didn't do anything yet, I stopped it. I mean, the problem with Lua is very addictive. It's hard to stop if you start. So that's the thing. So I put some hardware specs there. So basically we have a 75 megahertz processor, that's 32-bit ARM without MMU, 8 megabyte RAM, 4 megabyte flash with Ethernet connection. And this is this thing. It's sold by Digi. The nice thing with it is if you use those devices, you actually get $100,000 worth of dollars of development kits and development software, which make it very affordable to do products that are not, millions in quantity. I mean, there are thousands, let's say. So that's the software stack we use. So with this Digi module, we get the ThreadX. That's a real-time operating system, very, very small and lightweight. We get Track, which is an IP stack, some drivers, file system. There is no operating system, like, it's not Linux. You cannot do things with it without your application. All of those things with some additional glue code is called Net Plus OS. And on top of that, we built this multi-Lua VM system with many, many additions to actually enable nice communications between different threads. Generally, it's like with those modules, we have this main base module that has this main CPU, and then there is a bus that connects the extension modules, and each of those extension modules has its own small CPU, a really, really small microcontroller. And the design idea is like this. With Lua, we get very quick development and flexibility, but with garbage collection, these times are sometimes not very good. So all the low-level protocol handling, bit bagging, and things like that are done by the microcontrollers. And this Lua-based software just talks with all those microcontrollers. They have their own buffering. So by that, we assure that we don't lose some packets. And if Lua is kind of stopped for 100 milliseconds or something because of garbage collection, it's not a problem. So the main thing, it's a Lua device. You can start multiple Lua states inside. What is unique compared to other things, I mean, libraries like rings, is that those VMs are something like outside of Lua. I mean, I will show it interactively. I can tell that to this module, start a new machine that's empty, and I can post messages inside with code to be executed, including code to load other code. And basically, that's how those things start. So the benefit it got us was that actually, I said, those protocols are quite slow. So if we start this device in a building that had 80 of those devices, it takes like 7-8 minutes until all the state for the entire building is scanned, like the output values of relays and things like that. So if we had to restart the module after each change, that would be painfully slow. With multiple VMs, we can just restart the VM that we are developing, inject code again, and it can start talk immediately with other VMs that didn't have to be restarted. Other thing is that that it makes it easier to develop parallel things, which had to run in parallel. Outside of those VMs, we have the communication channels between those. So there are ways to execute code from one VM in different VM synchronously or asynchronously. Just post a message. Each VM has like an incoming queue for messages. And we have something like a publish-subscribe channels. When one VM, there are like prefixes, let's say. You can post to a channel, and all the VMs that have subscriptions on that channel will get a notification that there was a message. There is no source information. I mean, it's like with assumption that somebody will listen to it. This is like a screen from this web interface. It's written in Flash and talks with the Lua software. So again, this was before because the CPU is not that powerful, so we were not able to run a kind of server-client application. It's mostly running in the client, and only when the configuration is changed, it saves XML files inside the modules. Each line is one Lua VM that runs inside. By each Lua, you see how much CPU it uses, how much memory. We have statistics, how many strings are there, just to see how libraries use resources. So all in all, the entire device is using, for Lua, is using 2.5 megabytes of RAM in normal operation, which is not that much. I mean, this 8 megabytes of flash of RAM we have, it's a very large amount for what we do. Actually, in the beginning, we were even slowing down the CPU from 75 megahertz to 35 because it wasn't needed to run that fast. And if we run it twice as slow, we could actually survive a 400 milliseconds power loss. And now, with all the recent addition, we had to gear up. So it's again 75 megahertz, and we can now survive only 100 milliseconds power loss. So now a few calls. So essentially we have like this VM library inside. You can start a new VM. You can assign it a memory quota that I will explain later why. It's not a hard quota, let's say. You can assign priority and a stack size. This is because of this track. I mean, there is no MMU, so there is no possibility for dynamic stack extension. So the heaviest user of the stack is the zip library. We can stop VMs, but we usually don't stop VMs. Get a list of VMs, so to like management APIs. If we want to call a different VM, we can call this VM execute, give the VM name, and just send a chunk of Lua code that is compiled and executed inside. There is another version that's asynchronous. This is the call, where it basically does the same thing, except you can actually get some results back. And then as an optimization, we did this quick call, which allows to pass a number of parameters, not just a string that has to be executed. And it also copies back the results. Currently, it doesn't copy tables, so it's like a simple parameters. I think we will make it nicer and recursive, so it actually can copy back and forth tables. The publish subscribe is again 3 simple functions. You can subscribe for a prefix. So basically, for example, if you subscribe for a test, then any anything that's posted for a channel test or test with something else will be provided to this handler function. You can also unsubscribe. To make some periodic operations in the VM, we have this timer function where you can put a delay in seconds. So we use the floats. And then it's executed after that time. One thing that's important is that each VM has a global lock, so only one thread executes inside. So it's very safe for programming. So if you want to do something in parallel, we do it multiple VMs. Or in case of some scanning procedures, for example, for one device like this, we have 80 of those, and each of them has, for example, 70 things you can read from it. Then for those things, we either have multiple coroutines, when the scanning procedure is kind of, for example, to read all the comments or things like that had to be done sequentially, we start coroutines. And for things that just run periodically, we just have timestamps and we update the timestamps after things change. So this is like output from this module. So we have here the VM name, the number of strings in the Lua VM, how much memory is being used right now, and how much memory is this limit, what is the state of VM, how many messages are in the queue, and how much CPU is used, as well as how much stack, and how much memory is wasted by the memory allocator. Because each block has like 8 bytes of some headers, and we actually want to know. This basically gives the information. If the memory allocation is small, but here is a big number, it means that the chunks are very, very small. So this is, again, actually we did some optimization and some additional libraries to make sure the memory doesn't explode, let's say. One thing that's kind of important here is this state in the beginning. So this is a VM that basically keeps a huge table, Lua table, that has a mapping between state, current value, and update timestamp. And anytime something changes, it's in this state, and the other VMs are only putting things in the state. And every time something changes, actually it's here. So we have this big state VM. We have virtual machines that talk with the hardware, and they update information in the state. Anytime the information in this table is changed, a message is posted that's like this state thing. So, for example, imagine in the state we have something that says hour and the current hour. Every time a clock VM that's not here changes the hour in the state, it will post a message, e.hour, and then anything that has rules or something that is based on the hour can process this as a trigger event. And on the other hand, to make it kind of easier to remember, if we have a state variables, for example, lcn.output.number of the device .number of the output, and we change, we want, for example, to turn the light on off, it's the command is like c dot whatever was this prefix, and the command like make it on, off, 100%, anything. With that, we had some, over the 4 years and more devices and some customers. Like, for example, we were first thinking that 20 of those is a large number, and then we had some customers that had 200 at the homes. So that really made some things that were working very nicely with 20 didn't work that nicely with 200. And in this skyscraper, 60 floors, actually there are 2,000 of those. But then we don't talk with all of them. So one thing, we had to implement dynamic priority changes of the VMs. So basically, it depends on the number of messages that are queued for each VM. So the more, if it grows above 4, then the VM is going up and up to offload the queues. So this was relatively simple. With memory, it was much more much harder. The devices, they practically run all the time. They are not switched off. In case they go wrong, they have actually 3 watchdogs inside. One has a separate chip, and another one in this module, and yet another is watching the memory. So what we were having problems with was the memory fragmentation, and those were big problems. We tried different algorithms. By default, those things, this track uses DOCLIA allocator, but there is no MMU, so it has kind of a tight hands with the optimization. We found out a memory allocator called TLSF, TLSF, that is much, much better. But still, with the default tuning parameters for the GC speed, if many of those VMs were running in parallel, we were running into issues. So basically, we have those quotas for regulating the speed of the garbage collectors. So if it gets to like 80% of the quota, we double the speed of a garbage collector. Practically, it has to run all the time. I mean, normally we run it much faster than the default settings, and then it has to speed up. In this list, you were showing there was like a F flag by one VM. So the VM that actually has this fast GC running is marked. And it uses a lot of CPU to run GC like that, but we have to. The other thing is kind of an emergency garbage collector. So we have more options than a single VM system. If one VM is running out of memory, we can actually just pause for a little, try again. Maybe other VM did release some memory in the meantime. After a few tries like this, like 300 milliseconds, if the one VM cannot get the memory it needs, it actually puts a global flag, like an emergency garbage collection. And then each VM that it's running since then will do a full GC until that VM gets the memory it needs. So that's usually enough. We had some other problems in implementing this. So one thing, we wanted to use bytecode for the software distribution. The problem with bytecode files is that they are much, much bigger than the source code files, which we solved in the first version by having them zipped inside. The bad thing was that actually the track, this software operating system that is inside does not allow multiple concurrent access to a single file. So actually we had to sequence the loading of each VMs. So not that 2 requires we're running at the same time at any time, which made the module start like for 5 minutes, maybe shorter, but I mean that was irritating. So that was the one thing. The other thing was that for the upgrades for the customer, we have a few hundreds of customers, and the upgrades are going quite often. We wanted to have something that has more metadata. So we devised this PAK file format. So this is essentially a binary file with headers and the directory of all the files inside. The files can be compressed. There is integrity checking on the entire file on individual files. And it's like a mountable. So we can mount that file, and if it's mounted, then it's very fast to access because the directory is all the time in the memory, all the offsets are always in the memory, and there is also a caching layer for these decompression chunks. And there was a question about endianness changes. So I quickly checked. So when we used zip files, we used this chunk spy. And this is a small tool that can change endianness of a binary Lua file. And now for this PAK file creation, which is also a Lua written tool, we use a cross-compiler patch for eLua. So it adds like 2 parameters for Lua C that enable you to set the integer size and the endianness. So we use quite a lot of Lua libraries from the BDOPs. For binary protocols is very important, Struct, Lua Socket, Copas, Xavanti, parts of it. and custom libraries. So we have this VM library for the VM management. DIC is like for all the stuff that we didn't know where to put, like some encryption algorithms and things like that. And the management of the hardware itself, like configuring IP addresses, things like that. The binary is a library for binary arrays. So that's one of those memory optimizations. So we frequently have to keep, for example, information about 200 or 256 of something, like 8 bits of data or just a bit. So with Lua table, it just takes insane amount of memory for the memory we have. So we use those binary things all the time. So basically, you can create one. You say how many slots are there and what's the format of each item. It can be signed or unsigned, integer, byte, or long, or float. The bits, we thought that, I mean, we don't keep that many bits to make a big difference between 8 bits and 1 bit. So we can index it as an array. And, for example, to keep a temperature history or generally some logging data, we can roll by 1. So it's actually like a circular thing. So there's not much copying involved. And we keep like a history for temperatures. For example, for every temperature sensor we find, we keep 24 hours of history. Another library that I thought we will use very soon, but it was kind of delayed, is a packet. So the packet is something similar that enables us to manage sequences of bytes, but we can easily add something in the beginning or add something in the tail without doing another allocation. So we can pre-allocate like additional 8 bytes for headers, 8 bytes for trailer. And actually that's something we kind of miss in Lua. I mean, the thing I like about Erlang is this binary pattern matching. If that was in Lua, I would just, I don't know what I would do. But it would help us so much. So this is like a very, very simple and poor man's attempt to at least have some things. And of course, if we go that way, this packet should be a type we can pass between different VMs. Because typically what happens is, for example, there is one VM that gets the data from the extension module that the packet is received. It checks something, then posts, for example, for a channel, bus.lcn.received. Then it's different VM that actually gets that packet, the codes, checks addressing. If it's like a state update, it updates this state VM, and so on, So we work with packets all the time. One thing I also looked at, this is in Wireshark. That might be, I mean, they have a very, very nice library inside for packet manipulation. Okay, so now I will show a few things. So I can start with just showing the module, how it works. So this is this Flash-based configuration interface. You can log in inside. And unfortunately, I forgot to actually copy something interesting inside. So this first thing is you can define like a control menu for the iPhone or the iPad. You can define visualizations. So for example, I can quickly do something like a calculator. So we put a text field. We ask it to get data from channel var test, for example, and as an optimization, anything that does not exist means it's 0 or empty string. And we can put 2 buttons, for example, or switch. And the command, we can say that var test equals hello. And now if I press it, actually I have to enter this work mode. I press it and it's hello. So what happened was that the c.var.test equals hello was sent as a comment, and this var is a prefix for like a variables, state variables. Actually, if I go to the state, you see that this var test did appear inside. Typically in an installation you have hundreds of items here. And with events, actually, what you can do is define an event. So for example, anytime something comes on var test. We don't do matching, and this basically translates to Lua rules underneath. So you can use Lua regular expressions. You can put some conditions, which are also Lua expressions. And you can make a comment. For example, this is like an easy interface for the installers. We can say that module 20 have the output number 2. Or relays, for example, that turn those 2 relays and toggle number 6. And that's a rule. So that's like this simple thing installers do. There are some timers. And this is for things which is not possible. I mean, we didn't thought about. So this is basically a Lua, slightly with these environments, restricted version of Lua, because we don't want customers to use some methods that actually lock the threads, like the socket methods and so on. So there is like a subset, and that's why we are still using 5.1.4, because this 5.2 actually changed a lot how the environments work, and we didn't make it work yet. Basically, you just type Lua code here. It has some things different. For example, we can do something like that. C is use var test. So use is, of course, a function that takes one string parameters and returns an object that has some callbacks. So then we can do function C on change, new value, old value, and just do print something like that. We can save it. And now, oops, okay. Thank you. Okay, I actually show it works. Really. What I can show now is here we have a console. So we have some messages. I add another button. And just do it hello to. Click. And now if I look at the console, we actually have this message that is changed from hello to hello to. Actually, it should also display in here. So also it's here for installers. So those things are actually for doing anything we didn't do. So for example, the entire thing for the hospital, where they, on the visualization, they can set, for example, that from hour 7 to 8, light color should change from one RGB values to a different RGB values, and have many things like that, and do the very, very slow ramp over a few hours. They don't actually change colors. They change this white color of white. Yes? It should. What do you? Maybe I just found a bug. Change. Wait a second. Maybe I did press this twice or something. But then it wouldn't say it was changed because it executes only one. Let me check again. We change it to hello. No, okay, was weird. Okay, maybe that was because before it didn't have any value, so it was changed for the first time. We also, for bigger buildings, we have ability to kind of make an interaction between multiple of those devices, and there's those links, and some other things. So now the funniest part. So we have console, we can telnet inside. That's the office address. And this is like a command line interface, so we can show all the Lua VMs that are inside. We have the statistics about the memory usage. For the debugging of the allocators and things like that, we can also do something like heap start. that goes through entire heap in the TLSF, calculates the block sizes, gives us the smallest block size, the largest block size. We actually can even do things like heap free, and this lists all the blocks that are currently free. So this is also good for debugging memory leaks. After it runs for a while and we stop all the VMs and there are blocks of memory that are still used, we can actually see inside each of those blocks. For example, just see what was there. That was something. So sometimes you will see a string or something that gives insight what it could be when it did leak. Because there is no memory management unit, so the leaks can be tricky to debug. Also, what we can see is to see the list of these subscriptions. So here we have the name of the VM, the prefix that is subscribed, and how many messages was sent for that. And I can quickly start a VM and, for example, execute some code inside. Actually, I will execute that. And now in the console, we see it's running. And that's also nice for debugging, that you can run inside the device and interactively look at some libraries, so anything. So this is also something we use that's not, I mean, actually I'm showing it first time, so probably a lot of people start to use it. So that's how it works. So let's go back here. So, well, plans for future. We hope to finally make these environments in a new way working. I did approach the LuaJIT once or twice, but it's quite hard to integrate. I mean, it's not as easy as with Lua when we can put it in a project, we compile everything and it works. It actually has a lot of makefiles. And another problem is with the NDNS. So the standard LuaJIT right now does not support the NDNS we have inside. So I don't know how much effort will be required to actually support this other NDNS on the ARM. Another thing we would like to have is the SQLite. Right now, for the user to store some variables, there is, like we have the var channels, we have our mem channels, and actually not to wear off the flash chip inside, there is additional ferromagnetic memory from the company Ramtron. So you can put like 8 kilobytes of compressed variables that are stored there in like a transactional manner. So there's like a circular buffer with 2 versions and checksums. So it's quite robust. The new version, we actually talk with Digi now about making a special, I mean, the same thing, but especially for us, that will have 16 megabytes of RAM and 8 megabytes of flash, and different pinout, so we can actually use faster connectivity from inside, because that's like a limitation in this thing, that it has 12 pins. Yes? Could you repeat louder? So this thing, it has, I mean, depending what you need, you can reconfigure, but there are some limitations what you can put out. So right now we are using serial link, we are using I2C, we are using 2 or 3 binary inputs, and in theory we could connect a SD card, but there are some bugs in the hardware, and we have problems with that. So we are actually designing now a new hardware that will use it differently. And also we'll move, because right now some of those VMs, I mean the bus between extension modules is like a master-slave. So the VM modules, I can actually show that as well. So if we disconnect here and connect again, I can also talk directly to this embedded CPU inside, and this is like a command to the board number 1, show version. So I have the firmware version inside, and this is the LCN interface, so I could send the send command and send some packet. That, of course, is not a good command. So this means send that string over the link. And I have bus 1G, and it says no packets were received. The problem is that for each of the hardware modules, there have to be a VM that's constantly querying those boards, and that's actually kind of wasteful to do it from Lua, but it's master slave, so we have to query. So the new hardware, we actually use different serial link, and all the modules will be multi-master, and we will use bigger CPUs, not the very, very small ones, but the STM32, and they will be able to keep the information about, for example, attached intrusion detection system inside. And instead of sending information about a received packet, they will send information about changed state variable. So basically, Lua will only be triggered if something changes, and not right now as it is. It has to run in loops all the time to see if anything changed. If we get this bigger memory, we will use the SQLite. So the SQLite is extremely small database, but it's 300 kilobytes. So for now, it's too expensive for us. 300 is a lot. So also we think a little as a kind of a side project with FPGAs, and one idea we had is to actually use a specific hardware that would speed up execution of Lua. For example, have additional if we have a memory, actually don't make a 32-bit memory, make it, for example, 36-bit memory, and keep some tags in this additional memory, or, for example, to fight fragmentation, have a hardware-based lookup table for object access. And then we could actually move like a secondary CPU that would, in the FPGA, you can have many CPUs in one chip, to have a second CPU that would run garbage collection algorithms globally for all the VMs, and the primary CPU, much bigger, would run the code. So as a summary, we were extremely happy with Lua. It enabled us to create a product with a very small team. I mean, as a kind of competition, that the competition is still working on it. And we have it for like 3 years now. It runs quite nicely in the very small hardware. I mean, if we double the capacity, just 150 megahertz, that's nothing. But it will actually run super fast. This multiple VM thing, well, actually, it's very nice for the development. It made things easy to test. And what's also very important for us is actually showing Lua for end users and installers, electricians. It's actually not mind-boggling. I mean, it is mind-boggling for them, but programming is hard. I mean, and they just usually, I mean, frequently they just copy and paste some examples, and they are happy that the lights in the closet doesn't turn off when you walk through the motion detector, and some rules triggered. So that's like if they do it for the customers, it's usually the customer says, for example, you know, every time at 6 p.m. I would like this window to close, and then it's easy. And then next day he comes, but not if I'm watching TV. So then person does something, and the next day they call. But you know, I also told you that if the alarm system is on, all the windows should open. And you know, next customers say that of course they should close when the alarm goes on. So the next day they come again and they say, you know, I was watching TV, my wife triggered the alarm system and the windows open and I couldn't watch TV. So it's like a lot of exceptions. So actually we plan to have like a different approach for the configuration, not by logic rules that, you know, this Boolean algebra is kind of foreign for electricians, but by, you know, it should happen like that, except, and a lot of exceptions. So that would be it from me. So the question, please. No, so we sell it as a product. We do trainings for them. So usually what they do, they install this system, and it's very nice, but it lacks this central device that would actually do some logic. The company that makes that has a product for that, but it runs on a PC, and it's not very convenient to keep PCs running all over the place, especially if you think some installations we have, for example, is a multi-apartment building, where it's, for example, small building, apartments, and each apartment has its own independent installation, and then actually the servers are hidden in the electrical closets that the customers don't have to make place for them. So it's essentially a part of a building. Did that answer your question?
When there is when an electrician comes and installs the system, and then, as you explained, the customer is coming again and again with exception to the exception to the exception of the rule he has forgotten about, it sounds like quite time-consuming customer care. So I was wondering how it was working for them business-wise. Do they build a first installation, then bill by the hour when they modify the installation?
Yeah, so usually they don't build them. The customer says like that. I mean, I paid 30,000 for this home automation system, and it should do to sell that, they have to promise a lot. So actually, there's also a kind of a conflict, because the manufacturers of home automation systems, they do promise a lot on their web pages. It will do everything. But what they sell is actually devices that don't do anything unless you program them. So the promise is it will do anything. It do whatever it's programmed inside, and then it's the electricians that actually do the programming. So there are some gaps. So that's, again, a different idea we have at some point. We want to make a device that will have much more built-in rules, so they can more like select the typical things a customer wants instead of configuring it all the time. And for this business model also, with our device, they actually can reprogram other systems and our device remotely. So that makes it very, business-wise, very, very efficient for them. They don't have to go there all the time. Yes?
So since this system is connected to the internet, so those customers can monitor it, what are the security provisions? I mean, what prevents somebody from actually hacking from outside into the system and then wreak havoc in it? Thank you.
So typically they are not exposed to internet at all. There are some ports like integration protocol, for example, that we didn't protect. It's just, anything that changes, you just see it there. What is the recommended way of using those devices is to use a router with a firewall. No connections are allowed to the device, except for connections to these programming ports. For this LCN, but then there is username and password. We had to use the protocol the LCN uses, and it's not encrypted, so they can use with the software. But for the remote control from the iPhone, for example, or iPad, this is extremely well secured. So basically it's like this. At the moment you get this device and you want to connect an iPhone or iPad, you generate here a single-use password, which is valid for 1 minute. And then in the local network, they talk together. They use elliptic curve cryptography to establish independently encryption keys. And then all the communication is encoded with the encryption keys. At the moment when you clear this remote authorization, it actually establishes a random ID that's called pairing ID. And this thing registers in our server with this random number. And then this remote thing talks to a server and asks if that random number is connected, and then the server starts to pass messages between two parties. But we are not aware who or what that is. We don't want to know.
Thank you.
Did you evaluate the possibility to actually use coroutines instead of full-blown Lua state or VMs?
Yes, so we do use coroutines in many of those VMs, but they are not, I mean, if we do networking, it's much harder to work with coroutines. And then again, the fact that we have multiple VMs actually is a very big benefit for us, because it makes this memory management kind of a parallel, much more wasteful, of course. And you know, for some things, we can just treat it as exclusive machine. So, and then with coroutines, actually we would have some concurrency issues, because we would have to always remember not to kind of leave some changes in the middle in one coroutine compared to the very, very different one. And with those logs, I mean, usually it's one file that loads inside each VM, and then it uses some other libraries, but essentially it's encapsulated. So even if there are some global variables that leak out because of lack of local keyword, they affect only one VM and not the entire system.
Could you go back to the slide where you had all of the libraries you were using real quick? Yeah, okay. So one thing, I mean, the previous question may have already covered it in your answer to the question about coroutines. Inside VMs, in some cases, you do use coroutines. Did you look at, there's a synchronous, like I think it's a research project, but it's a synchronous extension to Lua called Lua Gravity. And it kind of, it implements a sort of estoral kind of synchronous concurrency model. Rather than having a kind of asynchronous concurrency model. Is that something that came up when you guys were looking about how to model a concurrency inside a given VM?
So I don't know about the project. I mean, the VMs, in the beginning, we were planning 3 VMs. Okay. One was supposed to be like a system VM for low-level things. The other was kind of integration VM. And the third was for the user code. It kind of grown.
Just exploded. The other thing is... at one point, you mentioned wanting a kind of functionality like Erlang's binary, like bitstring comprehension. I don't know of anything in Lua that actually does the bitstring comprehension, but there is a library called Lua bitstring that basically gives you a analogous syntax. I don't think that they do 1-bit byte. They won't go, like unlike Erlang and modern Erlang, they won't go down to dealing at the 1-bit level. I think they treat everything as a binary is 8 bits to a byte. But there is a syntax to be able to use that, and there's some examples about how to use it with Wireshark to do protocol decoding. Like they use it to, they have an example where they do EAP TLS decoding and so forth. So you can get that kind of...
This is written in Lua? Or
yeah.
Okay, so that might be a problem, because we do a lot of that, and if it's in Lua, it actually might tackle...
There's a C component to it, but I think there is like a require for... I believe there is a part that's written in C, just the packing and unpacking.
Oh, okay, we'll make sure to note which library it is.
One thing I'm curious about is, how do you get much pushback from your user community in terms of the installers that use the system? Like what sort of training do you give them and so on?
So right now we don't have much of a formal training. This Lua part, and actually I should mention that I wish it looked like yours, is basically it's like this. All the other things except the logic tab, we have a full documentation. For this logic tab, we kind of miss a lot of documentation. So right now we don't have that many requests here. So we simply say customers that if they want to, I mean, they should never say to customer that it's not possible. But if they don't know how to do it, they should just reach out to us and we will help to write and provide some examples to build upon.
Just to follow up on that real briefly, I think elsewhere in the industry, the bar is set pretty low in terms of the interfaces exposed to integrators and customization capabilities, at least in some of for example, the ELK alarm system I have here in the US has got some rule capability, but it's extraordinarily limited. And I wish I had anything approaching this available to use. My question is, when you talked about your publish subscribe messaging system, Do you extend that to the expansion modules that are connected to the system over the serial interface? Do they directly publish into that?
No. So currently it's only between VMs, and the new design actually is planned to do that. So we'll have a CAN bus between the modules, and there the CAN events will be directly visible to the VMs in both ways. Because, for example, we started with this bus, for example, for DMX, that we can control 256 light. And recently, a few projects came where they actually want to control a few thousands of lights, like a facade of a building or something, and that's too much. So the new hardware is actually designed to reach to things we were not even possible to reach when we started the development.
Very nice, thanks.
Okay, so I think we are quite over time. So thank you very much, and let's look at the robots.